Okay, so as I mentioned at the beginning of the meeting, Dalton and I have wanted to go into a house and conduct a worst case draft test for a while and just record it so that we could look at it as a whole program. So we were able to do this last week, I think it was. And I've tried to edit that video a little bit, but it is a 30-minute video. So I'm going to go ahead and hit play on it. And the goal of this is, as we've been out, we're seeing that you guys are doing a fantastic job doing your worst case draft tests. We're seeing a little bit of differences when it comes to setting up the doors in the house, particularly if you get into a central partitioning door. So we found a house that's a really good example of that, and so we've included that in the video. But I'm going to hit play on the video and let's watch it. And if you have any questions, we'll have a few minutes at the end where we can field some questions. So just make a note of those questions during the video, and then we'll take some time at the end. So if you have any issues with the audio or anything, speak up as I hit play on this so that we can make sure everybody can see and hear. Okay, so we're here in another client's home. We're going to go ahead and do a worst case CAS depressurization according to the BPI 1200 standard. We're going to use our worst case test form. We're going to, as long as you follow steps 1 through 12 on this form, then you will be in compliance with the BPI 1200 standard. This one's an interesting house because this room in here through this door is the CAS, where there's a closet in there, this CAS, and there are 2 doors into the CAS here, and there's another one off of this bathroom. So there's 3 doors connecting the CAS. Also, where these guys are standing, there's a great partitioning door that comes from upstairs. So at some point in our test, we'll be closing that door and figuring out what kind of effect that has on the CAS. Okay, so step number 1 is to put all the appliances in standby. So it says place all combustion appliances located within the CAS in their standby mode and prepare for operation. So we have the furnace turned off, and then we also have the water heater is set to either pilot or vacation. So we've completed step number 1. Step number 2 is to make sure that the fireplaces are off. It says fireplaces and wood stoves must be fully extinguished with no hot coals, and you want to close the dampers and the fireplace doors. This home actually has 2 fireplaces in it. This one here, we've actually just completed our blower door, and not only do we know that all the dampers are closed, but we also showed with an IR camera that there was no air leaking in this one. So we know this one's all closed down and ready to go. This fireplace actually has a balloon in it, so we know that its damper is closed as well. So the fireplaces are both off and dampered. The next one is to make sure all the exterior doors and windows are closed. Again, we just completed our blower door test, so we do have all of our exterior doors throughout the house closed. All the windows are closed and you're ready to go, but you just want to do a quick double check. Okay, step number 4 is to close all the CAS doors. So again, here I am from inside the CAS, and we have our furnace and our water heater are inside this closet. The closet is louvered, so really we are talking about closing this door here. We have another door over here, and then back in the back of our CAS, we have a 3rd door, which you can access from this room. So this door is closed. Now, these should not make much of a difference because they all are vented. So they have some jumper ducts through the doors, but we will close them because that is the step on our test. So make sure these are closed. The next step is to set all the interior door positions. As you can read here, it says to close the interior doors of all rooms except for rooms with an exhaust fan and rooms with a central forced air return system, or system return, sorry. So we'll go through the house and close all the doors where if there's only a supply and there's no return in that room, we're going to close that door. Or if there's no exhaust fan in the room. So, okay, so that one just has a supply register in it. It's just a bedroom. This one is a bedroom that's connected to a bathroom. And in the bathroom, we do have a second door so we can isolate that room. So that bedroom only has a supply in it. But now this bathroom does have an exhaust fan, and it probably has a supply down there. But either way, because it has an exhaust fan, we're going to go ahead and leave these doors open to the rest of the house. And then also, we've got a couple of returns here in the hallway. But really, there's no doors to close there, so it doesn't really matter. But just, we've got these two doors closed, but we have the door open to the bathroom. And then all of the other main areas up here on the main floor are just open. They do all connect to the basement through this door. But again, this is a central partitioning door that we'll deal with in a minute. Downstairs, we're going to have all these CAS doors closed. But we do have one bedroom over here that we will close the door on that room since there's no exhaust fans in there. And then we have one bedroom in here, and there is an exhaust fan in, or bathroom, sorry. There is an exhaust fan in there, so we're going to leave that one open. So once we go back in here and close this CAS door, then all of our interior doors and our CAS doors are in the right position for the test. All right, step number 6 is mechanical ventilation needs to be turned off. So we're going to turn off any mechanical ventilation and forced air or cooling and heating systems. So as we got ready here, we already have our heating system and our air conditioning is off. Upstairs, well, in the bedroom or the bathroom over here, we already know that that fan was turned off. And then there's one other fan upstairs. There's not a fan in the kitchen, so we really just have the 2 bathroom fans, and we have verified that both of them are off. So step number 7 is to go ahead and get our starting pressure. It says measure and record the baseline pressure in the CAS with reference to the outside. So we've got our manometer set up here in the CAS, and we have sorry, the lighting's a little low in here, but you can see we have the left side of our manometer. We have the input tap is open to the CAS, and then this reference hose, this green one, is actually going to the outside. So we're referencing the CAS with reference to the outside, and it is giving us a pressure. Now over on the right hand side, in a few minutes, we're actually going to be measuring the pressure of the draft on the water heater, or whatever the pressure is inside the vent. We'll be measuring that over here, and that's, we've got our hose going up into the vent right here, and then the reference tap is open, so we are measuring the vent pressure with reference to the CAS on channel B. Okay, so because our CAS actually has these louvered doors, we want to close them as well. So we are really considering these doors and this door over here and the one behind the equipment. Those are all our CAS doors, and we're supposed to start with them in a closed position. So we've set our manometer up inside here with all the hoses that I just showed you, but we've closed the louvered doors. Dalton's got his phone connected to that manometer through Wi-Fi so we can see what's going on. And again, on channel A, that's our CAS pressure. So looks like it's bouncing around a little bit. And again, we're looking for our worst case CAS, which means we're going to go for whatever makes it the most negative.
If yours is bouncing around a lot, you can change the delay to like a 5-second average or a 10-second average, and that will help. That will mathematically average out the numbers for you. So I think Dalton just switched it to a 5-second average. We'll go with a negative 1.8. Okay, so that's step number 7. We recorded that we have a negative 1.8. Now, step number 8 is to turn our exhaust equipment on. It says turn clothes dryers on. You want to check and clean the dryer filter and verify there's no blockage in there. Any range hoods or other exhaust fans that are exhausting to the outside. And it says operate exhaust equipment at the higher speed settings. So if you have any ASHRAE fans that they're set up to move like, 40 or 50 CFM all the time, but if you can flip them on high, they'll kick up to like 90 CFM. You need to be turning them on high. And then it says do not operate a whole house cooling exhaust fan. So if you ever run into that, you wouldn't want to operate that at all. And then again, we're measuring and recording the pressure in the CAS with reference to the outside. So our exhaust equipment here, Dalton's going to turn on the dryer. He's verified that the lint trap is clean, and also the outside of the termination, everything looks nice and clean. We don't have any major blockage there. So we're going to kick that on in here in the CAS. So in the basement bathroom, we just turn on the exhaust fan. And then up here in the master bath, we have a fan here, and it is set. This one works both as a continuous ASHRAE, but also local exhaust. And by turning on the local exhaust switch, it will turn it to its highest speed. And I can hear it starting to ramp up. So that's all of our exhaust fans. Now we're just watching again on channel A. We're watching to see how that impacts our CAS pressure. We'll let this ramp up and normalize a little bit and then record it. So now we're hanging around -5. So just by turning those fans on, it has put our CAS at -5.0 for our exhaust equipment. Next step is going to be to turn on our air handler. And as number 9 says, number 9 and 10, determine and indicate the condition above that causes the greatest CAS depressurization. Measure and record the greatest depressurization. So our goal here on number 9 and also on number 10 is we have to identify whether the air handler is going to be on or off to give us the worst depressurization. So to do that, you have to turn the air handler on to the highest speed that it could possibly go to during normal use and operation. So if your air handler, under an emergency heat call or a call for heat for a long period of time, if it's modulating or two-staged, you need to make sure that it's going to ramp up to its highest speed. If your air handler has an air conditioner on it, that will run at its highest speed. Typically, and so you'll actually just want to go pull the disconnect and kick on your air conditioner. So let's do that. Okay, so out here at the air conditioner, we are just going to either switch it off if it's a switch, or in this case, you just pull this out and pull the whole panel apart. You just pull this disconnect out and set it aside. You're going to have to do that anytime it's cold outside so that you don't damage the equipment. That way, when we turn our air conditioner on, that won't turn the equipment on out here. And then here at the thermostat, we're just gonna go to cooling mode and turn it way down so that the furnace will kick on in AC mode. So back in the CAS, we can hear the air handler starting to ramp up. We'll give it just a minute and see what our CAS pressure is doing. Okay, with our air handler on, it looks like it's putting the CAS in just slightly worse condition than it was before. So the -5.6 with our air handler on would be worse than the 5.0 that we had when the air handler was off. So if this had actually caused the CAS to go more positive, then we would show that the air handler is supposed to be off, and you'd leave that at a negative 5.0. But since having the air handler on did put the CAS in worse depressurization, then we're recording saying it's on and a negative 5.6. Okay, the next step is the CAS doors. So we started out with all the CAS doors closed. We're going to go ahead and open them, and we're going to see what that does to our CAS pressure. And then let's take a look at our, oh yeah, and probably kick these louver doors open a little bit, and let's just see what kind of effect that has. And it is a little windy today, so our pressure's bouncing around a little bit. We've averaged it out to 10 seconds now. And let's just let it normalize here for a second. So started out at 5.7, dropped down to a negative 4.7, negative 4.1. So it looks like it is actually putting our CAS in more negative, into a more negative pressure, or under more negative pressure, when these doors are closed. So we're going to leave them closed. We're going to document that on the form that they are closed, and the CAS pressure when they are closed is that same negative 5.6. And then the last thing is alternate door positions. Now, if you feel very strongly about it, you could go throughout the house with a manometer, and you can actually do a zonal pressure test on every door if you want to. Feel free to do that. If you do that, then you're going to document that on step number 11. But please note, on step number 11, there's this little asterisk here that is actually required. So anytime you get into a house where there are central partitioning doors, like the one we have at the bottom of the stairs in this house, you are required to basically do exactly what you just did with number 10. You're going to test it while it's open, and you're going to test it while it's closed, and you're going to figure out which position puts the CAS into a greater or more negative pressure. So let's go and close that door. So again, this is just the door at the bottom of the stairs. I'm going to close that, and then we'll, oh yeah, just close our CAS door. So closing the partition door, we got our CAS doors closed, and then we're just watching our manometer here. And with that door open, our greatest depressurization was negative 5.6. Let's give it a second for pressures to normalize here. So it looks like it's gone a little more positive when we open this door or close this door. Yeah, so we're going to go ahead and open it, and we'll keep watching our manometer for a minute. Let's see if this will go back up, back closer to that 5.6 or not. So opening it back up is making it go a little more negative. With the fluctuating wind pressures outside, we may not get back to the negative 5, but we want to determine if this has any impact on the CAS. Kind of bouncing around. Yeah, close it again and see if it changes anything. So negative 2.6. Back to 5 seconds. So again, with it closed, we're at, right around negative 2.9, negative 3.0. And then let's open it and see what it does to the pressure. Looks like it does go slightly more negative.
We've got the other gauge and test it.
Yeah, so where it's bouncing around, let's do what Dalton's saying. We're going to use a manometer and do a zonal real quick to be for certain on this one. Okay, so Dalton's got another manometer here, and he's just doing a zonal. So he's just got the hose under the door, and we're just testing pressure. So and as we expected, there's not a huge pressure difference from this side of the door to that side of the door.
So it's not affected.
And that's why we're not seeing it change the CAS pressure very much. So, and where it's this close, could really go either way. So Dalton basically just changed the hoses so that it is as if we're now standing on the other side of the door.
Not really. There's not much pressure between the two.
Yeah. Okay, so in this case, we're going to go ahead and indicate that this door is really not having an impact on the CAS pressure. And so we'll just show that our worst case conditions are what we found a while ago. And I'll go ahead and record those.
Well, sure.
Okay, so on our alternate door positions, I put an NA because, as my notes indicate, the door at the bottom of the stairs has no impact on the CAS pressure. If we actually found that it made the CAS go more negative, like say it went to negative 6.3 or something, then we would actually record the 6.3, the negative 6.3 here, and then down here we would describe that, you know, the door was closed, and that's you know, the door at the bottom of the stairs was closed, and that's what caused it to go more negative. So, but since it's not having an impact at all, we want to make that note. And then number 12, all we're doing is carrying this down. We're just saying the worst case conditions we got it into was a negative 5.6. And so we now know that our worst case CAS pressure is negative 5.6. So at this point, we now want to move on to the second part of our test, and that's where we actually measure the vent pressure of the appliance that we're trying to measure or trying to test, which is the water heater. So water heater in this case, we need to measure it at 2 minutes. So after we fired it at 2 minutes, we want to know what the vent pressure is. Again, we're measuring that on channel B on Dalton's phone, but Dalton's going to go ahead and he's going to fire the water heater, and we have a timer here. As soon as the water heater fires, we will start the timer. Did it go?
Yeah, it fired.
All right. And then again, we're trying to keep the CAS in worst case conditions, so we're closing the door, and then we're watching the manometer. And as I mentioned, this channel A is bouncing around a little bit, but now we're watching channel B, and we want to know at the 2 minute mark whether or not this appliance is drafting. As you can see, we're already at a negative number, so we know it is drafting. And it's, you know, at a negative 4 is a pretty decent draft, but we'll go ahead and check back at the 2 minute mark and see where we're at. All right, so we're getting close to our 2 minute mark here. And as you can see on channel B, we are still quite negative. So negative 6.3. So we have a nice strong draft. So our vent pressure is negative 6.3 for the water heater. So water heater does pass our, it does have an acceptable draft. There is one other piece of information we want to collect here, and that is we want to know what the CO is on the water heater at the 5 minute mark. The 5 minute mark is when we are under a steady state efficiency, or basically the appliance has been burning long enough so that it should be a nice clean burn. So we've added 3 more minutes to our timer. So once we hit, you know, the end of this time, then we should be at 5 minutes, and we'll be able to take a combustion test on our water heater. Now you'll notice when we do this, we still want the water heater under worst case conditions, because if the water heater ever gets choked and is starving for air, then the CO levels could rise. So we want to measure our CO with the appliance under worst case. Okay, so on our water heater, we need to get our combustion analyzer down into the flue a little bit so that we're down below the dilution air that's coming in. And then looks like we're coming up on, we got about 40 more seconds. But we'll go ahead and kick our pump on. We'll start watching things. Now, we've been able to see that these louver doors really have no effect on our CAS worst case, so we've kicked them open because the CAS is still is just as negative with them open or closed. And just gonna watch here when we get to the 5-minute mark, which we're almost at. Be able to see. So we're looking at our flue temps. We want to make sure that we're up to normal flue temps for a water heater, so we should be somewhere up north of 300 degrees. And let's see, we've got 1 part per million on CO. But the BPI standard is the air-free measurement, which is this one right here. So our CO air-free is at 2. And I'm going to go ahead and hit print, maybe. So with this, I'm just going to record what our CO was, and then just want to finish out the test. So we had a water heater that it passed worst case. So our conclusion is that all of our category 1 combustion appliances are venting safely. And then I'm going to go ahead and sign and date this, and that's it. We have completed this test.
All right. What did you guys think? What questions did you have as we went through that video? Is there anything you noticed in that video that it helped you to better understand how to do it? Are you wondering why we did anything in any particular way?
It's a little vague when it asks you it's the bottom question on the form on the left.
Which number is it? Sorry.
It's the bottom question on the left of the form.
Oh, let me pull it up, or let me make it bigger here. The bottom question on the left. Are you talking about number 6? Or further down?
Under the vent temp, it's asking whether it's cold or whether it's warm.
Oh, thank you for bringing this up.
How long has it been off?
Yes, I'm glad you brought this up. We actually, while we were running that test, we talked about this because it can be confusing. The BPI 1200 standard, whether you agree with it or not, this is what the standard says. The standard says if you're measuring the vent pressure on an appliance where the vent is cold, then you need to measure that appliance at 5 minutes after the appliance has been fired and running for 5 minutes when the vent is cold. It also says that if you are measuring the vent pressure on a water heater, an atmospheric drafting water heater, whether it's cold or hot, you measure that at 2 minutes. If you are measuring the vent pressure on an appliance, like a furnace, and the vent is already warm when you started your test, then you measure the vent pressure at 2 minutes. So I've set the form up so that you're going to select, if this was a furnace, if we're testing a furnace and the vent is cold, then you would just say it's a furnace and you tested it with a cold vent, and then after the 5 minutes you'd say, well, the vent pressure is a negative 3.5 or whatever it is. But if it was a furnace and the vent was warm already when you started your test, then you would just indicate that the vent was warm and you'd take your vent pressure at 2 minutes. Or if it was a water heater, you're always, always, always going to select that it was a water heater that you tested, and you're going to test that at 2 minutes. Does that help?
Yes.
Yes, it does. Thank you.
Cool. Yeah, I have my own opinions about that, but we have adopted the BPI 1200 standard because it is a nationally recognized standard and because it is a good standard. So we just set the form up to reflect that. Thank you for bringing that up. What other questions did you guys have? I don't know how well the video showed the actual layout of the house.
Hey, Turner, did you see the chat comment there? Carrie Lynn says her mic's not working.
Oh, no, I did not.
And the CO on a water heater needs to be recorded at 5 minutes.
Repeat the question real quick.
Well, she's saying that then the CO on the water heater needs to be recorded at 5 minutes.
Yes. So the form says CO at 5 minutes, and that is because that's when the appliance actually reaches steady state.
Yeah.
So yes, you'd run the water heater, you'd measure the vent pressure at the 2 minute mark, but then you'd let the water heater burn for 3 more minutes so that you would hit steady state at 5 minutes, and you'd measure the CO. And the CO must be measured while the appliance is under worst case draft. If this is a category 1 appliance with an open combustion that can be impacted by the pressures in the CAS, it must be measured, the CO must be measured under worst case. If the appliance is a category 4, sealed combustion appliance, then you're going to measure your CO when it hits steady state, but it doesn't matter. It's not required under the BPI for that to be measured under worst case. And in fact, that is not part of this test. You'll notice that on that house, there was a furnace and a water heater, and we only measure the water heater. And that is because we're doing worst case tests only on, I guess it doesn't say it at the top of this. We're only doing that on category 1 appliances. So any of the other appliances do not need to be included on this form. But when you're collecting your combustion analysis, under that section of your audit, and when you're testing those during the closeout or the QCI, you still test those. They're just not part of this test. And one thing I didn't really point out well in the video is my form showed that after we measured the vent pressure that it passed. But if we had a water heater that had 430 parts per million, it actually does not pass. It fails. So these two things are a measure of whether or not we pass the worst case test. It could vent just fine, but have high CO, and we would consider that a failed appliance, and we would write a corrective action. So in that case, we'd say it failed. We'd name the water heater, and we'd come up with a plan with the homeowner to decide how best to fix that. And we would have the client sign that and agree that's what they're going to do. So thank you for that comment. Any other questions or comments? Have you guys run into any weird situations with those central partitioning doors? I don't know how great of an example the video was. You may have heard me clicking around during the video. I just took a second to draw up kind of the layout. So this was the main floor of that house, and then this was the basement. And down here at the bottom of the stairs, this is what we would consider a central partitioning door. There was that door at the bottom of the stairs. When you're going through and setting up all of your doors, you go into each room and you say, okay, if this room has a supply register in it and no central returns and no fans, then I'm going to close that door. So in this case, we closed this door and we closed this door on this bedroom because it only had a supply. We left this door open on this bathroom because it had an exhaust fan. We closed this bedroom door here. And then we didn't have any other doors to close upstairs. But we still have this large area upstairs with some central returns in it. And we really don't know how that's going to impact the pressure until we start closing that central partitioning door. So we've been in a few homes lately during our monitoring where we have closed some central partitioning doors, and we're getting drastically different numbers than what was recorded on the worst case tests. So if you have any questions about those, give us a call, give Dalton or myself a call anytime. If you're in the house, we can FaceTime with you. We can help you decide. We can walk you through that test where Dalton actually got the manometer out and tested the pressure under the door and was able to determine, in this case, I almost wish we would have had a greater pressure differential because it would have been clearer, the results. This case, it showed that since the pressure was the same on this side of the door versus this side of the door, this door really had no impact on our CAS. But when you get those stronger pressure differentials, then it makes it much clearer whether you need the door open or closed. In fact, help me with this because my brain's not working right, Dalton. What would have been a good example of when we would have needed to close this door?
Yep. So if you, how we had the manometer originally set up, where I had that zone with reference to our CAS, basically, if we would have shut that door and had a really high pressure reading, we would have wanted to keep the door closed, because that means the zone upstairs has a higher pressure and it's trying to feed our CAS more air, basically. And if vice versa, if I would have shut that door and we had a really negative pressure, we would have wanted to leave it open, because then that means the upstairs is actually pulling air out of our CAS and making it more negative. So
thank you for that. Any other questions?
And we can do a more in-depth training on that at some point.
Yeah, I feel like this one really just takes practice in a number of different homes. Go ahead.
Hey, when you're testing your water heater, the flue, depending on the water heater, that 5-minute mark will change. If you leave in that flue, sometimes your CO will climb. So if you record it at a 5-minute mark, and then later on you check it again, your CO number will probably drop sometime. So just keep an eye on that. I'd wait for steady state, but don't leave your probe in the flue too long. Otherwise, you're gonna wear your filter on your combustion analyzer.
On Brandon, on my end, your comment was a bit garbled. And I didn't quite understand your comment. Did anybody get the gist of it, of the comment?
Yeah, he basically is saying to not leave your combustion analyzer in the flue the whole time, the whole 5 minutes while you're waiting for it to get to steady state, because he's saying you could burn through your filter or your CO quicker.
Oh, like you can actually kind of
sensor,
clog
I guess.
the sensors and filters on your combustion analyzer.
Yeah, I think he was saying it's better to let it get to the 5-minute mark and then put the probe, then start taking the reading.
So
you're not. because part of his comment was too, when you first, if your combustion analyzer is already in the flue and you fire up the water heater, it can kind of spike out your gauge right away. And so I think Brandon's comment was to, fire up the water heater as far as when you're getting ready to do combustion and let it run for the 5 minutes before you stick the probe in the flue to take the reading.
Awesome. Thanks.
Yeah. Was that correct?
He's muted. Any other comments or questions about this? Awesome. Well, our time is spent, but that I will be posting. I'll be posting that video separately, and then I'll also just post the whole meeting on our YouTube channel. So if that's a resource that would help you in the future, you can look that video up there.